Well, welcome back, Caeden Dooner. You're one of our first re-interviews, as they say, as we are looking forward to getting some updates on what's been happening since the first time that we interviewed you. For our listeners, the last time we interviewed you, it was along with Owen Welch, and I believe you were both sharing with us the beginnings of what you were hoping was going to turn into the AMARIS Lunar Rover. And I know that you had done some background research, and now you're off to universities, both you and Owen, and you have a larger team to report out on. So tell us a little bit about who you are. Just remind our listeners who you are and how you came to be involved with what we're doing, and then how you became an aerospace engineer student.
Right. So thank you for having me back. It's always a pleasure to be back on these. Uh, my name is Caeden Dooner. I was on one of these, I think 2 years ago now. It's been a while. Um, I'm now a sophomore in my second year university student at the University of Central Florida. I'm majoring in aerospace engineering, and still definitely working in the group. I'm sure a lot of you heard about the CubeSat Development Teams. Still the Wolfpack and many of the other various clubs that have been mentioned on here. I still definitely work with them a lot. The main highlight from the last one I was on was the AMARIS Lunar Rover, and we have had a lot of progress on that. But talking about university and like major, it's definitely been a different experience. I know that a lot of the students that you've talked to haven't really had the chance to get into university. I know I'm one of the first like graduating classes that I moved on to university, but it's definitely a different experience, and I'd be very happy to talk a lot about that. There's a lot to say, a lot new experiences with that. So.
Yeah, we'll definitely get to that. But for those who are listening for the first time who might not know what the AMARIS Lunar Rover is, maybe you could give us a little background on what it is, how it began, and then that will lead kind of where you guys are now.
Yeah, of course. So the AMARIS Lunar Rover is an idea as of right now, and that idea is to create a 1U sized lunar rover, very small lunar rover, and use CubeSat technologies with that. Since we've had experience with CubeSats a couple times, we've had two of them launch, and we're working on another one right now within your group, actually. So um, a lot of our team members have had experience with CubeSats in the past, so we want to move away from actually doing just a regular CubeSat, and we want to create a lunar rover that, again, uses those CubeSat technologies, since that's what we're familiar with. And there's a lot of advantages and disadvantages to using that. But we want to look at the advantages of why using a smaller scale lunar rover would be beneficial on a lunar surface. But not only that, our whole like main mission is to mitigate lunar dust. And there have been a lot of research going on into that, especially from NASA in the recent years. And since the Apollo missions, when lunar dust became a major problem for them, we've had a lot of research done on that, and there's a lot of different ways. People already know of many different ways to mitigate that dust. In our experiments, we're looking at using electrostatics, and we've actually talked about using some chips that NASA's developed. I'm forgetting the name off the top of my head, but it's like a three-letter acronym for it. It's like EMS chips or something in regards to that. That literally just have like a magnetic, an electric field built into it, and like expels that dust away from the lunar rover. But what we've also shifted this experiment into is not only mitigating that dust, but to kind of track the particle motion of the dust and how the electrostatics and pushing this dust away by creating an electric field will alter the effect of the path of the dust particles. So our whole point is, yes, we want to get this rover up and running. It is a great opportunity to do that, and it's just great to say that you have. But we also want to look at a phenomenon that hasn't really been talked about, or not really talked about, but not really like known about, because it's very difficult to track that particle motion on the moon surface.
So you're saying, so like obviously with mitigation of the dust, it's because that could kind of clog whatever the movement would be happening of that. But you're saying that it might also actually help to, in not only to stop the clogging of it, but actually in the positioning and the movement of the rover itself.
Right. So dust does gather up, and especially on lunar rovers, what we have a problem with and what Apollo missions experienced was that their equipment was getting clogged with this dust because the dust is very finely sharped. It's small. It sticks to everything, and it has some hazardous properties that you don't really want to get on your skin or inhale. So we want to get rid of it. And yes, for our rover, since it is small, we are at a risk of having a lot of clogging issues, especially because initially when we land on whatever rocket we choose to be on, there's going to be a giant dust cloud from when that rocket lands. So there's going to be a lot of dust movement going on, and we do not want that to affect our rover. And a lot of people are going to have difficulties with that. So that is definitely something we want to look at and fix.
Right. So there's I guess I'm thinking there's two sources of dust, right? You just mentioned descent and a lander on the surface with the rover or any vehicle, right? Will kick up dust. Secondly, we know that the sunlight kicks off electrons and the dust sort of hovers above the ground on its own just from a phenomena, on the surface. So which do you think, if you had to guess now, which is more of a concern, the initial dust when you land or just daytime on the surface of the moon? Or is it too early to make that call?
Both are definitely difficult to deal with. As you did say, the dust does hover over the moon's surface. That's always going on since the sunlight knocks off the electrons off and creates a positive charge with that. And when we land there, there's going to be a giant dust cloud. I would say, to answer that, we don't exactly know, but since that's kind of what we want to test as well. We want to see whether that giant dust cloud that forms when the lander lands, whether that really affects us, and we can get a lot of different data from giant dust clouds to just normal dust hovering over the moon's surface. So I would say just the sheer amount of dust that might be expelled from that landing is going to be a major problem. And that's where a lot of the experimentation is probably going to take place in that initial phase. Because, you're looking at a small rover. It's going to have a lot of power. It's going to have a lot of power constraints. The movement might be iffy, and there's definitely rocks and navigation that we need to work on for that.
Right.
But it's definitely going to take place with that dust cloud being there. So I would say right now the dust cloud is definitely one of our biggest concerns.
Right.
Tell us a little bit about the team. I know when we first talked to you, it was just you and Owen kind of had piggybacked off of some paper, information that you guys had presented on at a conference. But now you have people from not only around the United States, but even people from the world who are working on it. Is that right?
We have expanded out a lot. It was just Owen and I. And we were going to look at getting some middle school, high schoolers that have worked in different groups and worked on CubeSats before. I'm sure a lot of people have heard about them, but we were planning on just using them. But
you mean the Wolfpack students?
Right, exactly. The Wolfpack students. We were just planning on getting them, but through a lot of outreaching and just meeting people at conferences, we've gotten a lot of people from different universities. We have people in England and Germany. It's we're really expanding out, and they're getting their students from their universities. And
right.
Why don't you tell us the main players and maybe what parts they're playing in it, and that will kind of tell us what they're researching.
And let me set the stage. The Wolfpack is, a lot of them are local to where we are, so I have a lot more oversight. But you guys that grew up in the program, you are a lot more autonomous, if you will, at the university level. So you really do drive the train a lot more for your own project. So that's why it's so cool to see you guys have success, because you're doing it in large part without a lot of oversight from us.
Yeah. So share out the members of the group, and yourself included, what your roles are as you're trying to, obviously it's a theoretical proposition right now, but how is it going from theory to actual physical?
Right. So yes, Owen and I are mainly the people organizing this event. We both work on, currently we're both working on the experimentation process, and we're kind of just overviewing and making sure everything is getting done. We always hold these weekly meetings too. So we're always working on this, and obviously we're all university students, so we have to have time for our classes as well. But we are doing a lot of experimentation, Owen and I, on our own, and that's our main thing right now. We want to get that solidified so that we can have an idea.
When you say experimentation, what do you mean?
Experimentation, I mean by experimenting on the ground level with exolith, which is essentially just fake lunar dust that we use here, since we don't want to actually use real
Right.
stuff
So
that we can get our hands on.
ground-based studies in your labs, to simulate the environment on the moon. Is Owen is not an engineering major though, is he? Is he still physics?
He is physics, yeah. So I'm aerospace engineering. Owen is a physics major, and then the rest of our group, we have a couple of university students. Maxwell Friedman, I believe, was on one of your podcasts, and he is also on our team.
Where's he at? Is it George? He's not the one from
He's
Georgetown.
not Georgetown. No, that is
Worcester Poly, right? That's right. Worcester Poly.
WPI.
Yeah,
and
yeah, he's a genius. Whew.
He's very smart, and I don't exactly know what his major is, but what he's
I think
doing,
it's robotics engineering. He specifically chose WPI because of the robotics engineering program.
Is he working on like the coding portions of?
I think he's hardware, isn't he?
Hardware.
Yeah, not exactly the coding. He does have expertise in a lot of simulation and coding, and he's actually been our main source of like actual modeling. So thank you for him. But he's definitely doing the hardware right now, and so is the rest of our group. They're all doing hardware right now, and what they're doing is designing models for our team. They're getting materials set and ready. We don't have actual like pieces yet, so we want to create. And what we actually just met about too is I want a actual like somewhat finalized, detailed version of our rover modeled on SolidWorks, for example.
So you're looking at making a pretty good fidelity CAD model of your rover.
Do you still have somebody, the guy from Georgetown too, I believe? Because I know that you have the high school students over in Germany and UK, but who is the person from Georgetown? His name is escaping me.
Andre
Permui. Yeah, that's right.
Andres, yes. He is he's been caught up in some schoolwork, but yeah, he is also doing the hardware side, and I think he's looking to do some of the coding a lot as well. He's definitely been doing that, but he's over at Georgetown.
So you all attend these meetings, or is it mostly you and Owen, and then everyone's kind of working on their own and you just give them updates? Or how often do you all get together to kind of collaborate?
So at the beginning of this last year, we met once every week. At least we tried to. And Owen and I, we like to meet a little bit before as well, just so we can catch up, since we run experimentation mainly, and the other group can't really do that because they aren't in Florida. They aren't close to us at all. So they've been doing that. But Owen and I meet a little bit before those meetings, and we try to coordinate like what we want done, what we've been up to, and like trying to organize the group a little better and outreach. Then we meet with the whole team. We discuss what we've been doing, but recently we've been moving the meetings to bi-weekly, since we're university students. We got a lot of work going on. So
speaking of university, have you been able to utilize, how is the UCF lab and how has being part of the aerospace engineering program been helpful for you, or has it been helpful?
Yeah, UCF is definitely a big aerospace school. Like, we are very close to NASA. We have a lot of space activities. We are on the Space Coast. There's a lot going on here. We have a great program, and there's a lot of resources available to us. Specifically for me, I'm actually in a lab right now with Dr. El Gohari, who has also been on this podcast. And what he does is he has worked on, and I'm sure you remember him talking about this a little bit, but he worked on particle motion, and he liked to study how the lunar dust, or just even lunar dust particles, like move about, and like likes to look at models of them, and they do a lot of modeling, which is what I've been learning recently. It's very difficult. Like, they use a whole process on the web, not really web, but like their own apps. I'm forgetting the name of their.
Right. It's not like you can just shake up a bucket of dust and watch what happens, because that lunar dust is in a vacuum, right? It's in a vacuum, and you've got the radiation of space, and which is ionizing particles. It's a very complex. It seems like it would be fairly complex to model that and reduce gravity, right? You got a vacuum, reduce gravity, and you got some physics going on with the UV. I think it's UV that knocks the electrons off.
Mm-hmm. Yeah, and he's doing a lot of simulation there, since that's what he's been doing this whole time. And I met him last year, and somewhere last year, and ever since then we have kind of been combining this, because we've been working on this lunar dust project for a while now. It's definitely taking its time, but we are working on it heavily now. And essentially what Dr. Harry and I are trying to do is we're trying to combine these two projects. I had just mitigating lunar dust. He's been working on the simulation of particle motion, and now we want to combine them and look at how electrostatics and electromagnetic fields can actually affect the path that these particles, these dust particles, will take. And UCF, we have our labs, right? There's a lot of labs there. I think we have a couple chambers, like I know NASA has a couple that we have access to as well. Shake chambers, just places where we can pull vacuum. We have a lot of facilities that we can use and we have access to. So it's great if you're looking to do some experimentation.
I remember that was one of your problems that you had, was pulling an actual vacuum when you were trying to do your testing. So now you're at a university where you can actually do that for real.
It's very easy to pull a partial vacuum or reduce the pressure. It's very, very difficult to make a really good vacuum. Right. I guess a high altitude balloon would be pretty close to that's a much greater reduced. Well, I do know that UCF produces more engineers that work on the Space Coast, I think, than any other university. That's one of their sort of taglines. So you have access to labs. You're on the Space Coast. You seem like you're positioned for, you're in the right place at the right time. What has been some of your most enjoyable moments at the university? And maybe what are some of the areas that are,
challenging
you'd like to share with us? Yeah, they're the good, the bad, the ugly.
Right. So there's a lot of both, right? You're never going to get a perfect university or even any perfect place that you can really find out without having a problem. So university, it's a very different scenario than when you're in high school. And I know a lot of your students are just now reaching high school. They're going to be having a lot of concerns with universities and picking the right ones. Let's look at UCF at their aerospace program. There's a lot of students going into that. UCF is a giant school, and a lot of other schools have this problem as well. It's not just UCF. Giant schools, and the problem is when you're first going into university, there's a lot of kids who need to get their prerequisites done, which include Calc 1. They include like Physics 1, just your general classes that, almost every major has to take. So you're taking classes with nearly 1,000 students in them, and these professors they're trying to do their best. It is very difficult to teach to 1,000 university kids. I'm very sure about that. So it's not as hands-on, whereas high school, you have these relatively small classroom environments, 20, 30 kids, and the teacher kind of connects with you a little bit. You have the whole year to learn about what you're learning. College is different in that you have one semester, which is like 3-4 months. And in that time, you only meet a couple times a week. It's whatever your professor has. It's only for a little bit of time. And it's with a lot of other students. So you have to be prepared to get the work done on your own. You have to be prepared to have great time management skills. You have to be prepared to have some very tough semesters. Most people are looking at 4 or 5 classes, and you have to balance your workload. So it can be a lot for a lot of people coming in. So I do want to warn that for incoming university kids. Just be sure to
Yeah, I was just going to say, how does a student become more than just a number, right? I know what you mean. I always tell the story. I sat in row I, seat 17 in one of my freshman chemistry classes in an auditorium that was like 2 stories tall. How does a student go from a class of 1,000, like you're saying, to how do they get what they need, and how do they connect with the professor when you're one of 1,000?
Of course. Well, there's a lot of ways. Ultimately, it's going to come down to the student itself, whether you want the help or not. Your college is always going to offer a lot of programs and help for you. They know the classes are difficult. They know there's a lot of people. UCF, for example, has a lot of tutoring services. There's a lot of them almost for every major. There's a group that tells you what classes are difficult, and they have peer tutoring for them. Just for math, there's a whole tutoring area just for them. We have certain rooms and just whatever, just for all that tutoring. So if you really need the help, you can reach out to them. But if you want to make more of a connection, you want to make more of an effort, you got to talk to the professor. They have their office hours open. They're definitely there to help. And sometimes it can seem like they just aren't doing what you want them to do. And it can seem like that, but they ultimately want what's best for you. They're not trying to fail you. So you can always go talk to your professors. They have office hours always available. It's always good to go talk to them, and that kind of makes a personal connection. They kind of remember. I know a couple of classmates I've talked to. Even myself, I've gone to see some professors, ask them questions, and they start to know you after, and they start like you realize that there's difference because they realize you're trying your best, and they know that they're not trying to fail you. So definitely there's some personal connection there, but it ultimately comes down to you as a student.
Would you say, like, I think a lot of times students and even parents assume that when their kids are in these like AP classes or these IB classes where they get the credits already in high school, but I've also heard stories that sometimes they're still not prepared for the rigors of an aerospace engineering math or science class, say what, as opposed to what they got in high school. Have you found that to also be the case, that the classes are definitely more challenging?
Most definitely. It is not a high school class. It is a college level class. They aren't just looking at how you do problems like in high school, for example, or calculus. Um, they in high school looked at how you solve these problems, just generic ways, and they introduce you to them. It's a great introductory. I'm not doubting the level of expertise in that classroom and how it's not helpful. It's very helpful. But when you get into college, they don't just look at that. They look at why it works and how things work. They look at in-depth analysis of even these math problems. And it's not just aerospace engineering. It's all these majors that you come into high school with. For example, I was an IB. I took a lot of these classes and got a lot of credits for it. But you got to realize that the math and just STEM classes and any classes in general are always going to be more difficult than your high school classes because the amount of work, less time, they got to put more material on you in a smaller amount of time than in high school. And they want to get you the right information for you to succeed. These English classes are even a lot more difficult. So,
yeah, I remember there was a conceptual physics class that had very little math. They'd go out and drop stuff off of tall buildings, and it was very popular with the athletes. I'll say that. They met 2-3 times a week. And then there was physics for majors, right? Like STEM majors, engineers. You had 3 or 4 classes a week. You had a 3-hour lab a week. It was calculus based. So there are gradations, right? There are different levels of difficulty. But I totally agree with you that if you're a STEM major, you will have the most rigorous of especially the prerequisite calculus, physics, chemistry, etc.
Yeah. Before we get to our final kind of advice question for those listening, what are some of the difficulties that you're having with the Lunar Rover, either the team or getting it together, and what are the next steps for that?
Yeah, we are having a good amount of difficulties, and one of our main problems before the last time I was on this podcast was just being able to conduct that experiment. We didn't have a lot of access to things, and now we do. We have access to a lot, and we can really get some proper experiments running. But we are facing a good amount of problems. I would say one of the major problems is just finding time. So we're all university students. We all have got a lot going on, especially for me. A lot of us have jobs as well. So there's a way of balancing that and finding time. And, you don't always need to be doing work. You want some time off, and that's okay as well. But you have to find time. And for us trying to connect, like, I have my days and they have their own days. So just trying to connect in general, finding when everything can work out and when we can actually meet up is very difficult. In terms of actual experimentation, one of the main problems we're having is like coming down to a final experiment. And I know it sounds like we do, but it's kind of a broad topic still, mitigating lunar dust. And there's a lot to do with that. You could mitigate it in many ways. Even just materializing something on our rover, like using different materials, even like having some kind of wet substance there to kind of make it more difficult for the dust to stick there. There's a lot of ways you can do that.
So it's basically still the design area that you had mentioned earlier that you're working on. And that's why you want to get a CAD model kind of thing?
Somewhat. The CAD model is mainly there just so we can get a good idea of what it looks like. But we're a small rover, 1U. It's not big. For a rover, they're usually pretty big.
Yeah, you have an incredibly limited amount of power. and you have to only work. You probably won't survive the nighttime, the 2 weeks of extreme cold. And you're talking 200-300 grams probably for your whole payload. Actually, maybe even less than that with your drivetrain. So yeah, we're talking a very small payload. So you have to be very precise about what you're going to investigate. And how it's going to talk, right? How you're going to get that data back.
And it sounds kind of difficult in that, like, you're there at UCF and you have somebody who's kind of working in that field, but maybe not exactly the same. So you're kind of probably responsible for a chunk and then trying to relay that information back to the other parts. I can see where that would be challenging. Is there a timeline that you guys are working on trying is there a timeline to where you want to have this from theory down to where you're starting to actually build it?
We've got a little bit of a timeline, and that's always changing. But as of now, in the next, let's say, couple months, we don't have exact dates, but in the next couple months, we definitely want to get like a finalized model down. And the main reason we want that is to look at power constraints, look at size constraints, because our experiment, we want to record data, right? We want to get that data. We want to film it. We got to know how much space we're going to have. We got to know how much, whether we're going to be able to fit that, whether we have to rearrange some stuff.
Right.
And we want to finalize that.
Soon,
This sounds like it might end up becoming like a capstone project or, some senior design project for some of you.
Yeah, something that'll take some time. Sure. Well, as you are an editor of our podcast, it's one of the ways you definitely contribute to the team still. You know that we always try to wrap up our interviews with some overarching advice. I think you've already given some today about being aware, like, of time management when you get to university. But I guess in regards to aerospace engineering in general, what would you be, what anything else that you want to share with our listeners about?
What would you share with, let's say, a 12-year-old that says, I want to be an aerospace, or I just want to be an engineer? What do you tell the 12-year-old?
Well, they got to believe in themselves. As long as you really have that mindset on where you want to do something and you put your mind to it, you can get it done. I mean, I've seen 12-year-olds build CubeSats. They shouldn't be doing that, but they don't know how to do that, so they do it anyway. It's just a mindset thing, and if you can get through that, then you're going to be fine. There's a lot of good in university, and I know I've mentioned a couple of some of the difficulties, but there's a lot of good in it. You start getting older, you start getting into university, you have a lot more freedom, you have a lot more time, but then you start to learn your own life skills. You have to really, that's a time of development, and you have to just have these certain skills, and they're essential. Time management, just handling stress, just taking care of yourself is very important. Probably one of the more important things than anything, than even studying. If you're not in a good mindset, you're not going to be able to study, and it's going to keep you from doing well in university. So yes, there are some challenges to it. It's not an easy journey, but keep the mindset. You'll be okay. Just get through it, get what you need to get done. You don't have to have everything perfect. You don't have to have A's. You don't have to have B's. They say C's get degrees, and that's true. Just try to take what you can out of it. It's not always about getting the class done. You want to learn from it. I've had classes where I just don't care, gen ed, and there's just sometimes a lot of students are just like, oh, I don't care about this class, I'm not going to show up. But the main takeaway from college should be you wanting to learn. You're there, you're paying for these classes. You don't want to just not show up. You have the option to do it. You're free to do whatever you want. But you want to learn from it. You want to actually take these skills and learn from it. And that's part of the reason why I went and did math, like all the way from the beginning. I knew I didn't have a strong foundation in it, but I genuinely wanted to learn and get a better grasp on my math skills. And
you're saying because you could have used the credits, but you chose to go backwards because you knew that it was probably a better foundation.
Right. And that's up to you as well. But what I would say is take from college, don't just go in there just to get it done. Right. You want to gain some knowledge from it. You want to gain some very important life skills from it, and you will. There's a lot of development in that time.
Well, we look forward to maybe having you all come to the Small Set Education Conference again this year and share out as you make some progress, and hearing from you with some future updates. Thanks for spending some time with us today.
Yeah, thank you for having me again.
Thanks, Caeden.